Just copy the circuit in your note and tell me how it is working. Have two NMOS in the bottom. Okay, or I'll draw in some other way. Okay, I'll draw one NMOS like this, another NMOS in opposite way for ease of drawing, and it's connected down. This is NMOS, this is also NMOS. Clear? Okay. Now I'll draw again two PMOS also. One I draw. Sorry. Okay, one PMOS is like this, and the PMOS is like this. Okay. You just need to take some time to think what I'm trying. It's nothing complicated, very simple if you know the operation of those things. Okay. Now what I'm doing, I'm connecting the base together. That means the input of this PMOS is also connected to this NMOS. Similarly, this is also connected to this. And one more thing, I need to give the VDD here. I give a VDD or plus 5 volt. Plus 5 volt, or it is commonly told as scientific terminology VDD, maximum voltage. IC volt, whatever. Plus 5 volt. Okay. Okay. And this two input I take together as input A, and this two I take as input B. Okay. Now inputs are clear now. So B is going to two MOSes. So B input is going to P1 MOS and N1 MOS. P1 is a PMOS, P-type MOSFET, N1 is a N-type MOSFET. And same time A input is going to P2, second PMOS and N2. Clear? Now the question is input is ready. Input is going to P1 and B is going to P1 and N1, A is going to P2 and N2. Now I'm telling you my output. My output, I'm taking a point here, and I'm taking output at point V output. Ready? This connected to a point here. Both intersection of EMOS 0,000. Okay, so this completes my circuit. Okay, now you want to copy this same circuit in a notebook and think and see how the circuit is working. So how you understand? You just give input A and B some values starting from 0, 0, 0, 1, 1, 0, 1, 1. Okay. So give A and B some values like A, B, and each of these cases you find what is V output. What are the values? 0, 0. You see what is V output? 0, 1. Again 1, 0, 1, 1. Each of these cases you try to find the V out. What is the basic principle? When PMOS input gate voltage or control voltage of PMOS is low, it is on, and if it is low, and for NMOS it is off. And if the control voltage or gate voltage of NMOS is on or high, it is on. If it is low, it is off. Based on this two conditions, simple conditions of NMOS and PMOS, you just tell me what will be the output, V output, if this A and B are 0, 1, 1, 0, 1, 1, 0, 0, etc. All these conditions. Then tell me what is, based on your knowledge, what is the behavior of this circuit. I think you are trying. You should try. You can take maybe 3 minutes. So I'll always again repeat what we are trying to do. We are trying to understand the working of a transistor in a specific application, which is transistor as a switch. Switch is an abstraction of a transistor. When it is transistor base is given some voltage, it is becoming on or off. So I use that concept or that application or that property of a transistor to use or to make or design some transistor circuits where it is operating as a switch. So it is abstraction, right? It's a simple abstraction so that if the input voltage is high or low, the transistor is on and off. And there are two types of transistor, NMOS and PMOS, based on the opposite duality of operation. For NMOS, if high voltage in the base or control voltage, it makes it on. For PMOS, a low voltage makes it off. Okay. So yeah, you just draw the truth table. That is why I call you just draw the different possibilities like A and B. You see the V output. Okay, different values of V output. Sorry, different values of A and B. You see what is the V output coming, and tell me what is the property you're observing. What is the behavior of the circuit? Yes, you might have heard it before. You have learned it before. So you just think about that. After analyzing the circuit, you tell me what is the V output at each points and what is overall working of this circuit. Those are not completed, you again try it, you'll get it. It's not that difficult, but you need some patience. Yeah, there are different answers I'm getting. Some are saying it's an OR gate, some are saying NAND gate. Let's see majority. Let's see who is okay. I think now equal people are telling it's NOR gate and equal people are telling it's not gate, NAND gate. So at least I'm sure that last question we have designed a NOT gate or inverter. Okay, so right now we are trying to design gates, logical gates using transistors. I think you can remember we are designing logical gates using diodes. Okay, now we are discussing the use of logical gates using transistors. So there are four conditions you have to analyze, right? A and B. A and B can be high or low, 0 or 1. Okay, so the two inputs, that means two possibilities, 2 into 2. Right? A can be 0 1, B can be 0 1. So you already know if one thing can happen in n ways, another thing happen m ways, both things can combinedly happen, combined together can happen in m into n ways. So here A can happen in two ways, B can happen in two ways, 0 or 1, 0 or 1. So both A and B together can happen in 2 into 2 ways. That is 4 ways. So all the four you have to analyze. Again, people are getting NOR gate. So I think more people are getting the NOR gate. Please put in the chat whatever you're getting. Please put in the chat. Why I'm trying to do this in the class? Because if you do in the class, it will be more kind of discussion kind of class, so that you will be learning much more. If you're not willing to write in the notebook or think, analyze, I think it is your then you're wasting your time in the class. Because I already told this is not a theoretical. Analog circuits is a design oriented. Theory is required, but not as important sense as your design skills and your intuition about the circuits, your black box, your understanding about the devices, different operations, etc. Again, I think everyone is right now saturated to conclude that it is an OR gate. So I can say maybe NOR. Yeah, many people are coming to conclusion the same. So I can say you are yeah, more people if you can learn. Yeah, Kanaya is again telling the concept. So what is the gate? Kanaya, you are getting right, but you're not telling the gate. You forgot this is gate. Okay, fine. Leave it. Oh, you're right. Your answer is right. So someone other can read his answer and tell me what is gate is that. Okay, Omkar is again telling it's not gate. So let again, okay, yeah. I tell those who are all told NOR gate, I'm sorry, it is not NOR gate. Okay, so let's understand the working of. First of all, don't take the name terminology. I already told you don't need to buy hard anything. Yeah, let's see. Okay, so let's analyze start analyzing the circuit. Okay, starting if I say 0 0 1, first condition I'm taking 0 and 0. Okay, 0 and 0. Let's see what is the output here. Now when B is 0, so B is 0 means this B input is given 0, A input is given 0. So the top P1 is input, control input is 0. Okay, and N1 is also given 0. Okay, P1 is given 0 in the base, N1 is also given 0 in the base or control terminal, and P2 is also getting 0, and N2 is also getting 0. Okay, so we know PMOS is on when its control terminal is 0. So I can say here P1 and P2 are on because its control terminal is on. Right? So plus 5 is short circuited through P1 and P2 and coming in the output. At the same time, N1 and N2 are getting 0 in the base, so both are off. So they are disconnected. That means V output is disconnected from the ground and it is short circuited to VDD or high voltage. So V output becomes high, right? So first condition 0 0, my V output is high. Clear? Let's take second condition. When B input is becoming 1. Let's say I'm just changing the B. Okay, I'll just change here the value of B only. B is becoming 1. Okay. Now B becoming 1 means the PMOS is getting 1, NMOS also getting 1. PMOS getting 1 means it is off, so we don't need to worry about the PMOS. It is off, disconnected. NMOS getting 1 means it is on. That means it is on, short circuited. Okay. So now what happens? Now we can see there is no change in the circuit. Why? NMOS N1 is on, but N2 is off. So still there is no connection of the output to ground. And at the same time, P2 is still on. P2 is still on. So VDD is now also connected to the output. P output. Getting? So it doesn't make any change in the circuit behavior because parallel two switches are parallel on. P1 and P2 are on. One parallel switch I made it off. Still VDD is connected to ground. And two series switches N1 and N2 was off initially. Now one switch is on. That doesn't make any difference. Okay. So still the output still remains the same. That means output remains one only. Clear? Okay, uh, so what Kanaya told was wrong. Sorry. Uh, so I also couldn't realize at that time. Okay, so when 0 0 is 1, 0 1 is 1. Now 1 and 0. What happens in 1 and 0? Okay, let's see what happens in 1 and 0. Okay, that means here A is giving 1, A is given 1, B is given 0. Okay, B is given 0, P1 and N1 is getting 0 in the base, and A is given 1, so P2 and N2 is giving 1 in the base. Now what happens? We know 1 in the P1 means make it on. That means P1 is directly connected to V output. Plus 5 volt is coming in the world. And what about N1? N1 is off. N1 is off because the base is 0. So N1 is off. But N2 is on. Okay. And same time P2 is also off. Just see the circuit. We know V output is fully disconnected from the ground because N2 is off. But VDD is fully short circuited to V output because P1 is on. You can see P1 is on. So we can say V output is still high. V output at 0 0 it is high. 0 1 it is high. 1 0 it is also high. The last condition is 1 1. We are checking condition 1 1. What will happen when both are 1 1?